Alright, what's going on, you lovely people? So in this video we're going to be building a bunch of different relay circuits, just wherever I can find on the internet. So the first one I've got here is by Desolator. Here's his channel. Quite a good channel. I mean, he's got videos from like 11 years ago. So yeah man, I've watched a few of his videos before, to be honest with you. So this one's called Latching Relay Circuit with Reset, no transistor, no IC and no Arduino. People do get onto him a bit about how, like in the comments, about how it's not actually latching relay and how it's a non-latching relay made to be a latching relay. Whatever, I'm not getting into the technicalities of it. I just want to figure out how this circuit works. So I built it. Let me show you. I'll turn on my power supply, which is a bit loud. So on 5.6 volts. When I turn on the circuit by switching it on, nothing happens. When I press the button, it then latches on the output on the LED and that stays on. And then if I press the button again now, it won't turn off because it's latched on. A bit like the SR latch, but without the reset S latch, I suppose. So nothing happens. I then have to turn off the circuit. Wait, if I have it off, press the button, nothing happens. Turn it on, that. So it's you know, it's a good circuit. So let's build it and then we'll go through the explanation of it. This was actually quite challenging. If we look at his video, I should probably mention here, he actually builds it, and no offense to this guy, everybody kind of does this, but he builds it like this, you know, just connecting it onto the relay, a button, a switch, and the LED. I hate that, man. Like, for me, putting this schematic that he's got here onto this breadboard was bloody challenging, man. And doing it like that is just super confusing for me. So I want to try to use a breadboard, and that's what I've done here. So yeah, let's build it on a breadboard. I took some time to design the circuit that the guy's drawn on multisim, and I find that once I've made a circuit on multisim and then I've also built it on a breadboard, then I feel like I actually understand the circuit, because building it on a breadboard versus doing it on multisim for me are two completely different things. It's literally like two different circuits. So it took me a while to get it, but I do now get it. So we've got VCC. This is the switch to turn on the circuit, and then this is the push button to turn on the LED. So push button to LED. You've got the relay here, the diode. So one of the normally open connection here is left hanging, and the normally closed one is connected to VCC up to here, and so grounded. So let's just build this now on a breadboard. So obviously you need a breadboard, then you're going to need a relay. You're going to need a push button. Any switch will do. I've just got one of these big clunky ones, and I've attached some wires to it. So you need a switch that can obviously go into the breadboard. An LED. Obviously I'm just putting them anywhere for now. You need a resistor. I have here a 220 ohm one, but anything like, you know, not too high, not above 1000 would work. You need a diode, which is going to go across the relay, and then you need some wires as well, and or whatever these things are called, jumper cables. That's it. That's all you need to do to build this. So let's get started. Alright, so starting off with the relay, obviously you've got to figure out first what type of relay you've got. You see here I've got 8 pins, so that means I've got 2, it's a double switch inside the relay. So if you have 5, then you don't have the double one, so that's fine. Is it 5? Yeah, 5. So you need to figure out which are the 2 pins that you need to trigger the relay and cause to energize the coil, basically. So 2 ways you can do that. You can just turn on your power supply, stick it on 5 volts, and then you could just start touching it on things. I already know that mine, for example, if I put it onto here and then start touching, I'm not going to get a tweak, and it's this one. So you can see here, these 2 front 2 here, they're the ones that trigger the relay. Then now, my relay actually has, on the top here, you can see it's got that little diagram which tells me that this 1 to 16 here, oh, getting blurry. You can see here it says 1 to 16 is what magnetizes the coil, right? Then you've got 4 and 13, which is what's always going to be connected to the positive rail, right, to power. And then you got 6 and 11, which is when it's normally closed. So you got these 2 pins here, they're normally closed. You can see the numbering underneath there as well. 1, 4, 6, 8. Really nice relay, to be honest with you. The other ones that I have don't do this. And then 8 and 9, you can see that they're normally open. So to test that, right, I should be able to take my multimeter, go on to the what's this thing called again? I forgot. But continuity, that's it. The continuity part, right? So now we're expecting that this 4 and 13, so this is 13, this is 4. So if I hold on to 13, then now 11 should be connected, and you can see there's continuity between them. If I try 9, there's no continuity. So that's how you can figure out what's what on your relay. So let's stick this in our breadboard, just bearing in mind which ones are our magnetizing ones. So we need to, first thing is we want to put the diode across the coil of the relay. I'm not really sure why you do this. I should probably Google it. You know what? Let me Google it now. Let's figure out why we do this. So let's just read this together. So since an inductor, i.e. the relay coil, cannot change its current instantly, the flyback diode, which is this diode here, provides a path for the current when the coil was switched off. It provides a path for the current when the coil was switched off. Otherwise, the voltage spike will occur, causing arcing on switch contacts or possibly destroying switching transistors. Yeah. If you understood that, go you, not me. The only thing that matters really when you're putting a diode in is, firstly, you obviously have to know how to put it in parallel, which means just putting it across like this. And so now what matters is that relays, in terms of their coil, they don't have a polarity, right? It's just a coil that is being magnetized. So once you place the diode in like that, you've now given it a polarity, because obviously current can't go this way anymore because you put the diode in like that, and you can see where my diode is. So if I switch it like this now, again, it doesn't matter which way you put it in, just get it in, do you know what I mean? Oh dear. Okay, cool. So you put it in like that, right? So now current can no longer go this way. Let's start with that first then, right? And now what I'll do is I'll just connect this end of the relay to ground. Cool. Okay, so I've now grounded that part. Obviously I'm going to energize positive and negative both sides of this breadboard here. Cool. Okay, so let's put this to positive. This is a bit extra, but I'm going to do it anyways because it just helps me follow the schematic better. So this bit of positive bit here I'm going to use as this. So I'm going to connect this into here. And so now I've got this junction point right here. Let me use, here we go. This junction point right here, yeah, is this point here. So now I need to add the button, and then I'm going to have another wire coming away, which is going to go to the power of the relay. And then I'm going to have another one coming away, which is going to the LED. So let me first start by putting that button in there, right? So I'm going to place a button here, because this wire here is just a little bit here. Personally, I find it very hard to translate a schematic onto a breadboard. They're just two different things. So obviously with your push button, just look, you can see, you can see along the bottom there that that's where these two are connected. So I'm gonna go like this there, and so now with this push button here is now connected to this whole row, this whole column here and this whole column here are connected. So if I'd use the continuity meter, you'd see that this and this are connected, yeah? Then when I push the button, then this side, and this side will become connected. Okay, so now I've got the other side of this push button going up to the switch. So this is my switch. So I'm now going to have a wire coming on this side here. So what I could do is I could just put my switch, for example, like here. And so now I've got one end of my switch connected to the push button, and then the other end just has to go to VCC 5 volts. So I can just turn this and push this in onto this side here. So hopefully you've understood that. It's tricky. If you're new to this stuff and you're like, what did he just do there? Mate, just go through it again. It's difficult though. It is difficult. But so I've got the diode here. Then here I've got this junction over to here. I've got the push button here. And then coming up to the switch, which goes to VCC, which is this whole positive rail along here. Cool. Next part now, we'll go back to this junction, back to this point here, and then we're going to do a wire now, and we'll just do going all the way along to the LED. So let's just put a nice long wire here, a nice long wire here, coming to the positive end of the LED. So I can just stick my LED in here. So goes along there, and then take my resistor and now ground it. So hopefully you've got that. This junction here, which is this point here, I find it very useful to put it out onto a breadboard, because this is all just connected to the back of the relay. It gets mad confusing for me. So this junction here, going all the way along here to the LED, and then to the resistor, to ground. So now let's do this junction point here, which is just again from here. We're going to stick a wire here, and we're going to take it to the power pin on the relay, which is pin number 1 for me. See that pin there? Which is going to be this one here. Let's just lift it up and check. That pin there. There we go. It really, like, you know, when you do it step by step like this, it's not too bad, but it does look worse than it is. Now I think the guy's schematic, he had it connected the other way around. My schematic is wrong really. So what I'll do is, let me, because if you guys are following his video as well, it'll be good to make sure. 1 second. Alright, so I know what happened there. Basically, during my simulation, the multi-sim, the software I'm using, I had it the right way around, and then when I closed this switch, sorry, and then opened it again, but it latched and it closed this connector and opened this one. So when I just went back and turned off the simulation, it then came up like this. So basically the simulation messed it up and switched the 2 contacts around. So scrap this one. Here's the actual circuit that we need. So we need the normally open side of the relay to be connected to VCC up here, and we need the normally closed one to be left hanging. So here, this is my normally closed one, so I need to leave this one hanging, and then my normally open one here, I'm gonna send this one to VCC directly. So if I take this and then normally open from here, about 10 minutes later, I've got it somewhat in. But yeah, you can see there in terms of my pins, my last pin there, which is the normally open one, you can see on the top there, is sent to VCC. So push that back in. Okay, so we've got our pin here, the normally closed one, left floating. Now the only thing for me to do is, in terms of my breadboard, I just need to connect the 2 sides of this together. Basically these 2 rails, the positive rail, connect them together. And then now if I take my power supply, so if I turn on the power, nothing happens, right? We're not expecting anything to happen. Now if I press the button, so my switch is now on, I press the button and then the LED turns on. I press it again and again and again, nothing happens because it's latched on. If I then turn this off, oh, you didn't turn off? So dumb, I know what I did. So my switch has no impact on the circuit because I'm powering the positive rail and the negative rail regardless, and I've got my relay connected to the positive rail. This switch, it does nothing. Yeah, it plays no role. So what I need to do is I need to connect let's connect my push button to power, right? Then now I need this to be between my circuit and my power supply. So what I need is, this is my power supply pin. I need this to be connected to here, and then I need this grounded in here. And then so for example, if I just hold it together, then now when I switch it, that's off. Press the button, nothing happens. Switch it, now my circuit's on. Press the button. Oh, wait, what? Oh, and so connected it to ground, wrong pin. Alright, connected it to positive. Alright, now it's on. Press it. Turn it off. Cool. Press it, nothing happens. Turn it on, nothing happens. Press the button, turns on. Cool. So I just need this to be between my power from my power supply and then this positive rail. So what I can do is I can just connect it into anywhere really. Cool. And then now connect this to here. Alright, so now this is VCC, right, coming into here, and then this switch is between it. So if I turn it off, oh wait, this is on, turn it off, press the button, nothing happens, turn it on, press the button, there you go. So now the switch is actually doing something. Which makes sense, right? Alright, off, on, off, on. And that's it. So what I did wrong there was my push button, even though on my schematic here, I mean, I could make it so that it follows the schematic to the T, because right now this push button is going to VCC. I mean, it's not really though, because this VCC here is dependent upon this switch, right? So I suppose, yeah, it's going to this VCC rail, but this VCC rail isn't hot, and until it goes to this switch here, right? So there, and then hopefully that makes sense. I can't articulate it, but yeah, the switch is between my VCC and the button, which is what we want. We want the switch between the button and the VCC. We want the switch between VCC and the, I don't know, what do you call it? Pins on the relay? I don't know. The poles? I don't know. I don't know what to call this. But yeah, between the VCC and the relay, you want the switch, which is where it is right now. And then likewise between the LED. So yeah, switch does its job, turns off the whole circuit. Cool. Alright, let's jump on to the next relays. Actually, what the guy did in his videos, he swapped out the LED for a buzzer. So let me see if I got a buzzer, and then I might actually try a motor as well. Let's see if that works. Alright, so it should just be as simple as, obviously this buzzer doesn't have any polarity. Oh, can't see it. Just normal buzzer I got from Arduino kit. So if I just pull this out, I mean, does it have polarity? I don't know if this thing has polarity. But anyways, look, we'll check. Let's see. So pull out the LED, stick the buzzer right in its place, and then press button. Buzzer's now on. Press button. It won't turn off. And this could be really good for setting an alarm. I saw in a book where a guy, just turn it off. Basically, you could use this to set an alarm whereby, for example, you had the power switch somewhere else, and then when you walk into your house, let's say, for example, this is what I think about. If I had this switch, you know, being controlled by my phone, let's say it was connected to an Arduino, and it was, or ESP826 or whatever, and being controlled by my phone, this would be the main on-off switch, right? And then this would be, as I exit my house, I press the button and let's say it turns on the alarm circuit, right? Then it can only be turned off. Like now, you can't now turn off the buzzer or the alarm going off from here, no matter what you do, right? But me using my phone, turn it off. So that's kind of like, you know, that's what I've seen the relay be used for. And do you know what? I might actually even try and build that. That might be a fun little thing to do. Alright, let's try it with, I'm going to try with something else. I don't know if my relay can handle more voltage. I'm guessing it can, but let me try with something more powerful. Just switch the buzzer around. It turns out it does have polarity. You can see from the shorter and longer legs, so it doesn't work if you switch it the other way around. Alright, so it worked with the buzzer. I'm assuming it's going to work again with the motor as well. So I've got it on, press it, yay! And it's only at 5.5 volts as well. I'm going to crank it up, hopefully my resistor doesn't blow. I mean my relay. 9 volts right now. It's not going very fast. It actually won't, okay wait, my thing's limiting current. So, but yeah, it works. So turn it on, nothing happens. Press it, oh, it goes a lot faster. I mean, a bit faster. But yeah, now pressing it again, nothing will happen. It won't turn off until you disconnect it. So, I mean, there could be many use cases for this, but yeah, it's a non-latching relay that we've configured it so that it latches. And, you know, I think to describe the way it works, I probably should do that before we move on to the next circuit, right? So, once we press, we've got a VCC, and it's coming to this, I don't know what to call this, port on the relay. I'm going to go port, I don't know what to call it. The pin on the relay that should be powered to VCC, currently when the button is open and hasn't been pressed, is not being powered. And then now you got no voltage drop across this diode and across the relay on the coil. So the coil is not activated, and there's also no power. There's literally no power in the relay other than we've got a voltage on the normally open terminal. Which again, you know, since it's normally open, none of the rest of the relay can see that power except that one pin on the relay, right? So there's no effect on the relay at all. Again, over here, the LED isn't turned on. and we've got no voltage at all and no current at the LED. So all we have is voltage here at this S1 point and voltage here. That's it on the rest of the circuit, with obviously this switch being closed. Once we close this now, this is where everything happens, right? So now you get a voltage drop. You get a voltage difference between this point here, which becomes 5 volts, and this becomes 0 volts, which then triggers the coil. This then switches this contact to open and this contact to closed. Once this contact closes, now you got current, you got voltage and current flow here, and then the LED turns on. So I'm gonna ruin my schematic, but it's fine. So this one opens and this one closes, right? Once this closes, now you got current flow along here, and then now we've got the LED turning on. Cool. We also have current flow along here, right, back across the relay, even though it's not current flow because obviously current's not going to flow through here because of the diode. But we have voltage now here at this point again, and so then now there's still a voltage difference, and so because there's constantly a voltage difference across here, the relay stays on, and it stays with this one staying closed and this one staying opened. So now you opening this switch now, so this was closed, right? Now you opening it, it won't now disconnect the voltage from here, because you've obviously got it coming down here, right? Because we had voltage at this point regardless, because it's connected to VCC. So then now you got the voltage loop just going along here. And so, I mean, a good way to look at it is you have VCC coming down here to here at this point, right? Coming to the relay at this point here, and then coming back round here, and then to this point here, which is this point here. And so it's just basically a slightly longer connection to here. So it's pretty much as if the switch is closed. So now you opening and closing this button does nothing, because you've got voltage here, which means there's a voltage difference across the relay, which keeps the relay open, and then just keeps on repeating over and over again. And that's crazy, because I now fully understand that circuit by explaining it to you guys. So thanks for that. Yeah, that's cool, man. I can now extrapolate this circuit into something far more useful, like the alarm system, etc. Yeah, it's interesting. All right, I'm not going to start doing that now, because I know that's going to take me like 2 days to figure out by myself. So what I'm going to do is I'm going to go and find another video on YouTube. Maybe, hopefully YouTube, because learning from videos is much better. Hopefully YouTube. If not, then I'll go to those websites. But yeah, let's find another video. Alright, so here's another video. This is called DIY Relay Module, and it's made by Crazy Couple. Guy's got 13,000 subscribers, which is decent. I found the video very challenging to get through, to be honest with you. But to be fair to the guy, I mean, there just isn't anything else online anyways. So basically what he does is he takes, okay, let's go through. He takes this big chunky relay module that, you know, you can buy from anywhere, and he makes his own one. And I don't really understand the premise behind making your own one, other than he says that it's just a lot simpler. I mean, it's quite a lot of work to go through and print your own PCBs, but I think it might be a decent project for me to do, just because I've never actually made a PCB before. So that might be something that I might be worth doing. So I've got the circuit here. Looks a bit funny because of all the big looping wires, but if I just put the little jumper cables, it'll look a lot neater. It's literally just a big chunky resistor, which you don't really need. You can use a small one. A transistor, diode obviously, and a relay, and then you've got the LED. It is actually a super, well, it wasn't simple, but it is super simple. So this is his wiring diagram here, right? And so yeah, let's build it together. What I've done is I've actually I'll show you his bigger wiring diagram first. The video itself is mostly just about how relays work in a basic way, so there's not much to it, but this is the wiring diagram that he makes. And then here's the schematic for not this part here, but here you go. I've got my power supply on. Yeah, so here's the schematic for this part here. So let's yeah, let's get into it. So this is, I built this schematic on Multisim. Again, it was challenging, man. It was challenging. It took me a while, as you can see here. So yeah, let's go through how it works first, and then actually, you know what? I'll show you a demonstration. I think like I'm a demonstrate then tell me type of guy. So if I take this is my positive and negative input for my power supply, which is why I have my power supply on. Cool. And then here, this is the trigger part, and this is the ground. So all you got to do is you just got to get any sort of voltage to trigger the relay. Now you can trigger it at a much lower voltage because we're using the base of the transistor to trigger it. So I'll show you. I turn on my power supply. I got 5.3 volts here now. If I connect this to the bottom of this, so this is just a 1.5 volt battery. Yeah, I can hold that in place. I cannot hold it in place. Oh my gosh. Okay, there you go. And so literally the relay is being triggered by just a 1.5 volt battery. And the reason for that is because I've got the transistor set up in such a way, or not me, but this guy did it, crazy couple, in such a way that the base of transistor is actually what we're putting current to. So we only need a very, very small voltage. I'm not sure how low we could go really. On my multi-sim simulations, it went as low as 1 volt. Alright, so with this schematic, you can see here we've got 5 volts, right? Now, our LED is here, and this is what we're turning on. Okay, so 5 volts, resistor, obviously for the LED. Now we've got an open contact here. So obviously the LED has no connection to ground. But once you close this contact here, because this one's normally closed, right? So this is closed, and it's not connected to anything. But once you close this contact here, then what you get, a straight connection to ground, and so therefore the LED turns on. It's actually a super basic circuit. It's literally just 2 circuits. You've got 5 volts, resistor, LED, and then you got a switch there. All we need is something to close that switch, and so we've got our relay here, right? Because this whole thing here is the relay, right? That's the relay. So you've got our relay here, and then you got a transistor. So we need a voltage, you know, here, right? This is what we need. So we've already got 5 volts here. We need to give a voltage difference here at this point. So we've got our 2 volts here. Once we close this switch like this, then what you get is the transistor turns on, which then allows current to go through here, and we get a voltage drop. And so then therefore this, now the whole relay turns on, and that closes that switch, and then now you get a straight connection straight to ground, and therefore the LED lights up. I mean, it is just a super basic circuit. You got one, I mean, you could say basically, okay, maybe we draw it outside the transistor. One circuit here, and the other circuit here, including the transistor, and that's it. It's nice, you know. I must say the design is nice, and I think the fact that the guy put it on, he put it onto his own PCB, I actually like that. Let me just bring it up. This is his PCB that he made with just a relay. You know what? I mean, he's given his Gerber files there, so you could make your own. I'm thinking I might try and design my own PCB module thing with a relay. It might just be something fun to do. And so here he's using the trigger there to turn on and off the LED, which is the same thing that we was doing here by connecting this one to the top of the battery and to the bottom. So I don't know, is there a need for me to build this circuit on the breadboard? I think let's do it, because if you guys wanted to, it might be a bit confusing. So yeah, I'll pull all this out, we'll start again and build on the breadboard. Let's do this. So we need an LED, diode, relay, transistor, and a resistor. That's it. So let's stick our relay in. Obviously these two are our coil pins. I still haven't figured out what the correct name for all of this stuff is, but it's fine. Alright, so which way you put in the diode just sets the polarity. So we then just need to connect this to the positive rail, because we've got here diode to 5 volts. So let's do that. Alright, so that's connected to the positive rail. So now we need, let's do, done a diode. We can connect, okay, well, let's do the LED circuit first. So we've got a resistor being connected to the 5 volt rail as well. So we can just go resistor to 5 volts, okay, and then we've got an LED, and we've got the positive end of the LED being connected to the resistor, and then the negative end going towards the relay. And so now we've got the other end of the LED, the negative end, going towards the normally open contact on the relay. So my normally open is this last one here. Normally open, yep, is that the right one? Slightly off. Oh, I can never get these pins in, man. So the next pin across, which is the normally closed one, we leave that floating. And then the power pin on the relay that is normally connected to the power rail, this time it's actually going to the middle pin. It's actually going down to ground. So let's send that to ground. There we go. Right, so we've done this whole circuit here. So now we need to do the transistor coming from the negative end of the diode. So we got transistor, and then we're doing base emitter collector. No, base collector emitter, right? So the collector, which is I'm really a bit crappy with transistors. This is the collector. No, this. I don't know. 1 second. No stuff. Just Google it. Yeah, it's this one here. Can't see this pin here that I've extended out. This pin. This is the I don't know what it is. Collector. It's the collector, and it's going towards the diode. So let's connect it in like this. And so we need to connect this to the negative end of the diode. You can see here that after what, 2.5 years of electrical engineering, I can't tell my way around a transistor. And that just shows you how much practical stuff we actually do at uni. It's next to none. It's literally just all theory, man. All of the practical stuff I've learned from my YouTube channel, and you know, I haven't done like hardly anything with actual transistors, but give me the equations and I'll start doing all the equations for you. Alright, so negative end of the diode to the collector on the transistor, and then we got to the base of the transistor, we got our okay, well, let's just ground it. So the emitter is just going to ground, so we'll just stick that to ground. Hopefully this is helpful. If this is helpful for you guys, like the video. Alright, and then base is going to another, I don't know why I said we only needed one resistor. We definitely need two. Well, I know I said it actually, because I usually don't stick a resistor on my LED. There's no point, but it's fine, doesn't matter. Alright, so from the base or the transistor, which connect this one. So that's connected to that resistor there is connected to the base of the transistor, and then that's going to a voltage source. I could put a switch in there, but let's not bother for now. Or should I just do it? Go on then. I suppose then I can connect in a proper voltage source. So I've got a switch. You can do it without a switch. You don't need a switch. Now we just need a voltage source connected to ground, and then also connected to the other end of this switch. So we could just use a battery like you saw me use before. So if I just go, okay, connect one end to ground, right, and the other end to this side of the switch. Alright, I've got the switch successfully in, annoyingly. Now touch the voltage. Boom, there we go. But I think doing this on an actual breadboard, or sorry, on an actual PCB might be a fun thing to do. I suppose the only difference between this and just using a relay normally is that you've got a transistor doing the switching, so that way you only need a low base current. So that might be quite cool. Let's just drop a great video. Just built this. There we go. Cool. Alright guys, let's. I was gonna end this here, but I don't feel like I've learned enough about relays yet, so I'm gonna do another circuit. Hope you guys don't mind how long this is gonna be. Alright, let's have some fun now. So I've been searching through YouTube trying to find a different tutorial, and I'm not finding anything. I kind of expected it because I knew that, you know, on YouTube it's mostly simple stuff, right? So I need to go online and find some more. I still need simple circuits, but I need something a bit better. So what I'm going to do is, now I've just got an LED here flashing on the Raspberry Pi Pico, and I've got one of the pins going up and down, high low. So if I now I just need to find a ground pin. Okay, so what the plan now, this should work. I don't see why it shouldn't work. And then, okay, so I think I got like this pin 15 flashing, going up and down. So hopefully now, using this as a trigger, I should just be able to flash this LED on and off. We've got a ground pin here, and I got my pin. Oh, there you go. Okay, wait, hang on. So that's the bottom pin, right? Yeah, I'm sure I used that pin. The Raspberry Pi, you know, I personally would not recommend, if you guys are new, don't buy this. Stick to the Arduino Nano. This Pi Pico, as far as I can see, it's just good for all these guys that know what they're doing. But for normal people, this is annoying, man. I found this Pico super annoying to deal with. What's going on? It just worked. That's not working. Come on, man. Okay. The Pico is finicky. Unfortunately, I can't find any of my Arduinos, which is why I spent like 45 minutes figuring out how to get this code working on the Pico. I should have chosen the STM32 board, which I have. But anyways, yeah. So you can see here they're both flashing at the exact same time. That's because this code is just running a loop of just this pin 15 going high, and then it's just triggering the relay. So I mean, the good thing about this setup here is because you're triggering it with a transistor, I think this circuit over here, this LED, could be a high powered circuit. Maybe I could be turning on, I mean, I don't know if I could switch mains with this, but I could be starting a motor or something, right? And I'd be starting it with just a small amount of current from you know, from here. What's going on with this? From the Raspberry Pi Pico or any microcontroller into the transistor. So this is a cool, really cool circuit. You know, I could see myself doing a lot of different things with this. I just hope I can like use it a bit more. That's what I'm hoping for. So anyways, yeah, that's that circuit. Hopefully this isn't the end of the video, but if it is, love you guys, thank you very much. But hopefully I'll do another circuit.